All right, let's jump right in. We're going to tackle a scenario that gives pretty much every engineer a shot of adrenaline. Your production database is on fire. We're going to walk through the playbook that separates a panic-fueled, chaotic response from a calm, methodical, senior-level solution. So just picture this. It's the busiest time of day. All your dashboards are lighting up red. Queries that normally take, a few milliseconds are now crawling, taking 10 agonizing seconds to complete. Your apps are timing out. Customers are definitely noticing. The pressure is on. And then you get the page. You're the one on call. What do you do right now, in this moment? That's the one question we're here to answer. We're going to build out that plan, step by step. Now, look, one option is to panic. I guess you could call it a strategy, but it's not a very good one. A less experienced engineer might just start randomly restarting things. A senior engineer, though, they reach for their playbook, a structured, battle-tested methodology for figuring out what's wrong and fixing it. And this is that playbook. It's basically a 3-part framework. First, immediate triage. That's all about stopping the bleeding. Second, short-term fixes. You got to stabilize the patient. And third, long-term architecture. This is how you make sure this kind of thing never, ever happens again. Let's break down that first step. So we're in phase 1, immediate triage. The goal here is simple and singular. Get the system back up and running as fast and as safely as you can. This isn't about finding the most elegant solution. It's about quick, effective battlefield medicine. Before you can operate, you have to diagnose, right? Just like a doctor checks a patient's vital signs. The very first move is to check the database's core health metrics. You just can't fix what you can't see. So where do you look? Your first stop is almost always going to be CloudWatch. A senior engineer is immediately checking these 5 vital signs. Is the CPU completely pegged at 100%? Are we totally out of memory? Have we hit our connection limit? Are our disk operations just going through the roof? Or is there a massive queue of requests waiting on the disk? This dashboard gives you that crucial 30,000-foot view in seconds. Okay, beyond those core metrics, there are a couple of other quick things to check. First, could it just be connection exhaustion? Sometimes a misconfigured service goes haywire and tries to open thousands of connections, just swamping the database. Second, check the RDS event logs. Did AWS just do some maintenance? Was there a recent failover? These events can absolutely be the root cause. Okay, now we move from just observing to actually interrogating. This SQL query is an incredibly powerful tool. You're basically asking the database directly, hey, show me every single query that's been running for more than 5 seconds. This instantly shines a spotlight on the slow problem queries that are probably causing the whole traffic jam. And here is another critical query. This one checks for lock weights. This is what happens when one query is holding a lock on a row or a table, and a whole bunch of other queries are just stuck in line waiting for it to finish. If you see a long list here, that is a huge red flag that you've got a major contention problem. All right, you've done your diagnosis. Now it's time to act. Based on what you found, there are 2 main break glass in case of emergency options. First, if you've found one single bad query that's blocking everybody else, you kill it. It's surgical, and it can bring immediate relief. Second, if the whole system is just completely overloaded, you can do what's called a vertical scale, just bumping up the instance size to get more CPU and memory. It's a blunt instrument for sure that, hey, it works. Whew, the fire is out. The system is stable. For now. This brings us to phase 2, short-term fixes. The goal here is to secure the scene, build in some buffers, and make sure this doesn't happen again tomorrow when traffic spikes again. One of the most effective tools in the box for this is RDS Proxy. Think of it like a bouncer for your database. It sits between your apps and your database, and it manages the connection pool. So instead of every single request trying to open a brand new connection, the proxy just reuses existing ones, which is way, way more efficient. And this illustrates the difference perfectly. On the left, that's the problem, chaos. Every single function, especially in a serverless world like Lambda, is trying to open its own connection directly to the database. It leads to exhaustion fast. On the right, that's the solution. The RDS proxy stands in front, absorbing all those requests and funneling them through a nice, managed pool of connections. It protects your database from getting totally overwhelmed. So the short-term stabilization plan has 3 key parts. 1, get that RDS proxy in there. 2, if your app does a lot of reading, you add read replicas. This creates copies of your database that are just for handling read queries, things like searches or viewing profiles. That takes a huge load off your main database. And 3, you do some basic tuning, like adjusting the max connection setting to a number that actually makes sense for your workload. Okay, we've stabilized the system, but a great engineer knows that a fix isn't a solution. And that brings us to our final, and maybe most important phase, long-term architecture. This is where we stop firefighting and start fundamentally re-engineering the system so it's truly resilient. You know, a major part of long-term thinking is asking if you're even using the right tool for the job. Standard RDS MySQL is great, it really is. But for high-performance, high-concurrency applications, migrating to Aurora is often the right answer. It was literally built for the cloud, it can be up to 5 times faster, and its connection handling is way better. And for those workloads with really spiky, unpredictable traffic, Aurora Serverless can be an absolute game changer. So let's look at the full long-term strategy. Migrating to Aurora is a big one. Another is putting in a caching layer like ElastiCache. This stores your most frequently accessed data in super fast memory. You know, the fastest database query is the one you never have to make, and caching common requests just dramatically cuts down on database load. And finally, you dedicate real engineering time to deep query optimization and index tuning. This isn't a one-time fix, it's a continuous practice of keeping your database healthy. And this really brings us to the core philosophy here. Architecting for resilience isn't about patching holes. It's about designing a system that anticipates and gracefully handles the challenges you know are coming. More traffic, more features, more complexity, without falling over. It's a huge mindset shift from being reactive to being proactive. So I'll leave you with this one question to think about. Look at your own systems, your own architecture. Are you just patching up the problems from last week's outage? Or are you building a foundation that's strong enough to withstand the fire that's coming next year? The difference between those two approaches, well, it's everything.